Hello students, this is the first part of periodic functions, important part for trigonometry. Okay, today I am going to explain the concept of periodic functions. So I will explain the concept of periodic functions in two ways. First one is graphical approach, second one is algebraical approach. So first of all I want to explain the concept of periodic function graphically. Okay. Students, first of all I want to explain the definition of periodic in English. Observe here, if you open a dictionary, so it shows that periodic means appearing or occurrence and intervals. Observe here, Nana. Periodic means appearing or occurrence and at intervals. So what is the meaning of periodic function? Periodic, same meaning of periodic is same, function. So I want to explain the meaning of periodic function now. By the help of sine graph I will explain everything, Nana. So this is the graph of sine function. I can say y is equal to f of x is sine function, or I can say the y equal to f of x function, or f of x equal to sine x. So already I explained domain and range, everything. I want to write here domain. Domain is all real numbers, range is closed -1 to 1. So I want to define periodic means what? Periodic. For example, f of x is equal to y. Okay, x is input, y is output. So periodic means we want to find out a positive x, understood? Positive x, not only one value, interval, positive interval x, so that your outputs will come periodically. Such a way that you want to find an interval x in this function. Once again I am saying, observe students, f of x equal to y is depend upon x changes, y will change. Now I want to find out a value of x or a positive interval of x, so that the outputs will occur in an intervals repeatedly. For example, I will show you here. If you take your x value from 0 to pi, if you take, for example, if you take x values from 0 to pi, your y values from 0 to 1 only. 0 to 1. My intention is take a positive x value, take a positive x interval, so that your y value should be belongs to total range, such a way that we want to choose a x interval. If I chosen an x interval as 0 to pi, if you take x is from 0 to pi, your y values are 0 to 1, so 0 to 1 values are not in total in -1 to 1, it is a part of -1 to 1 only, but I want total -1 to 1, such a way that I want to choose a positive interval x. Okay, so observe here, if I can choose x values from 0 to 2 pi, if x is taken as 0 to 2 pi, observe here, if x is taken as 0 to 2 pi, this is 2 pi, Nana, this is 0 to pi, 1 extreme value, that is 1 will get for this x value, that is pi by 2. For 3 pi by 2, least value will get, that is -1. So all the values of x will get, all the outputs will get, that is -1 to 1. If you take x is from 0 to 2 pi, x is taken from 0 to 2 pi, so what happened to y, Nana? Y is belongs to all -1 to 1. One thing. Somebody will say, sir, if you take x is from 0 to 3 pi also, no problem. If 0 to 3 pi, he want take 0 to 3 pi, means 3 pi means here what happened, this is 2 pi, this is 3 pi, up to here, you want take x values up to here. So what happened now, this is x value, the corresponding y value, this is the corresponding graph. Okay, so what happened, I think up to here only, this is 2 pi, this is 3 pi, okay, this is pi, 2 pi, 3 pi. So what happened, if you take x is 0 to pi, then y also from -1 to 1 only. Okay, this is also correct, but what is my intention? You need to choose a small possible positive interval than 0 to 3 pi, this is least, no, 0 to 2 pi, understood? If you take 0 to 4 pi, for example, this is 4 pi, so this is 0, pi, 2 pi, 3 pi, 4 pi, this is 4 pi. Okay, if you take length is taken as 4 pi, here also you will get all the x values, all y values from -1 to 1 only. So I can take 0 to 4 pi also, no problem. So all y values are -1 to 1, but among 0 to pi, 0 to 3 pi, 0 to pi, which one is least? Nana? 0 to pi is the least. That means we want choose a positive interval on x-axis. Okay, it gives total outputs, that is from -1 to 1, or with the help of these x values you can complete total graph. Such positive interval is called period of that function, and such functions are called periodic functions. Now I will show you what is my explanation. I will show you. Observe. Yeah, what this explanation is saying, that means we need to choose x value. Nana, my students, if you take x is from 0 to 2 pi, what happened? So this is the graph of sine function from 0 to 2 pi. Means from 0 to 2 pi, if you take x is from 0 to 2 pi, so the graph is completes one cyclic. See, one cyclic. This is another cyclic. Observe, second cyclic. This is second cycle. It will complete one complete cycle. No, such x values length is called its period. I can say 2 pi is the period of sine function, and sine function is a periodic function. More generally, see here. So what is the meaning is that with the help of this graph, we will complete total graph. With the help of this graph, we can complete total graph. That is the meaning. Why I am saying this? With the help of this graph means, see here, what is this, Nana? This is 0. No, actually this is 2 pi only. Observe here, 0 to 2 pi. This one complete cycle completed. With the help of this length, I can complete total graph. I will show you. See here, this is another piece. Join this to a 2 pi. See, another piece, join 2 pi. Join this. What happened, Nana? So total sine graph is completing. No? At this side also can join. Total graph is completing. No? Another words, I will say, I will show you. See here, place this graph. Actually, this is this portion. Place at 2 pi. So total graph will coincide with 2 pi to 4 pi. Place at this point, total graph is coincide with 0 to -2 pi. Okay, means with the help of this length, means if you take x values from 0 to 2 pi positive, so you get a complete cycle. So that length is said to be the period of the function, and such functions are called periodic function. After this explanation, I can conclude that sine function is a periodic function with the period 2 pi. With the period 2 pi, this length here to here length 2 pi. Okay. So important thing is the interval should be positive. The interval should be positive, such a way that we want to choose a smallest interval. With the help of the smallest interval, we want to complete total graph of that function. So the functions are called periodic functions. The smallest length of that interval is called its period. So sine function is periodic function. Now I can say that least length is 2 pi. So 2 pi is the period of sine function. Yeah, okay students, now I want to take a graph of cos function. So now I want to check cos function periodic or not, then what is its period. So I want to use the definition. What the definition? Graphical definition. We want to choose a positive interval on x-axis. So with the help of that x values, we need to complete the total graph, or that x values gives one cycle of the graph. Means one cycle of the graph means it should give all the values from range. So positive. See here, if you take 0 to, so this length is pi by 2, this length is pi up to here 0 to pi. If you take the graph, Nana, we take, this is the piece, this is one cycle. I will show you. Wait, I will show you. Okay, I will show you. Okay, if you take, this is the graph. Yes, students, if you take, this is the piece. So what is the length, Nana, here? See, here 0, here 2 pi. This pi by 2, pi by 2, pi by 2. Total 2 pi length. Okay, if you take, this is the piece of the graph. Okay, place it. See here, exactly coincide, and it gives continuous graph. No? Place here. See, exactly coincide with the previous. Is what happened? This length, positive length 0 to, this length 0 to pi length is taken. No? This length 0 to 2 pi. So this piece is taken as the standard graph of the cos function, or if you take from x is from 0 to pi, what you are getting, all y values you are getting. All y values means what is -1 to 1 you are getting, range you are getting. So So that too, with the help of this piece you can complete total graph. Means what I can say that, so if you take x values from 0 to 2 pi, you can complete one cycle of the graph. Okay. So cos function also periodic function with period 2 pi. Okay students, now I want take next the function, that is f of x equal tan function. Now I want check whether tan function is periodic function or not. If it is periodic, what is the period? So what is the meaning of that? Now I want choose a x value, or I want choose an interval on x axis that should be positive, and with the help of that interval I can complete the total graph. Okay, observe here students, if I take this is the piece of the graph, see actually this is 0, pi and another pi, total length 2 pi length. In cos and sec the length is 2 pi, no, here what is pi by 2, pi only, length is pi here. So with the help of this graph I can complete total, or another words I can say that if x is taken from 0 to pi, so it gives one complete cycle of the graph. Observe here, I will show you. Place this here, see, coincide with previous, no? Actually this is here only, first cycle completed, see second cycle, see third cycle, this side also, see. That's why this length means what here, Nana? Pi by 2 plus total pi length, this pi length is taken as the period of the tan function, and function is said to be periodic function. So observe, Nana, sin function, cos functions periods are 2 pi length, but here what is the length, Nana? Pi only, see, pi by 2 plus pi by 2, pi. So tan function is a periodic function with a period of pi. Similarly cot function also periodic function with the pi, and second cosec also, I will show you it. Okay students, next my function is cot function, f of x equal cot x. Now I want choose an x value, positive x value on x interval on x axis, so that that interval gives a complete cycle of the graph of cot function. Observe here. So this one. So this is the graph, Nana. 0 to pi by 2 and pi by 2 pi. Total length is pi only. So place this graph here. See, observe here. See. Okay. Next, see here. Next, completing, no. That's why this is the one of the complete cycle of the cot graph with the length of pi. That's why pi is the period of the cot function, and cot function is said to be periodic function. Okay students, similarly we can say that secant function and cosecant function is also periodic function with period. This cosec function period is 2 pi, and as secant function period is 2 pi and cosecant period is 2 pi. So I will write sin function and cos function and tan function and cot function and secant function and cosecant functions are periodic functions. So period of first function is 2 pi, sin function also 2 pi, cos function 2 pi, tan function pi, cot function pi, cosecant function 2 pi, and secant function also 2 pi. So this is a graphical explanation and graphical approach. Now I will use algebraical approach. After completion of algebraic approach, you people get clear idea about periodic functions, Nana. Is said to be periodic function a function f, I can say a function f is said to be periodic function if there exists a positive real, say some t, so that f of x plus t or t plus x equal to f of x for every x belongs to domain. So this is the definition of periodic function. A function f is said to be periodic function if there exists a positive real t such that f of x plus t equal to f of x for every x belongs to domain. If any function satisfies this definition, the function is said to be periodic function. So I will explain through examples. For example, f of x is given sin x. Now you want to check it is periodic or not. How can you check? Means you need to see this definition. Just to write definition, f of t plus x should be equal to f of x for every x belongs to domain of that function. Just to write down f of x plus this is f of x, no, f of x is equal to sin x. F of 3 means what? Instead of x you want to write 3. F of 7 means what? You want to write instead of x you want to write 7. F of t plus x means what? So sin of t plus x should be equal to sin of x for every x belongs to domain. If such t exists here, then you can say that it is a periodic function. So by using definition only you can find a period and periodic, you can check it is periodic or not. Students, observe here. Instead of t, positive real should exist. Okay, for example, instead of t you write for example number 2. Sin 2 plus x is not equal to sin x, no? Sin 2 plus is not equal to sin x. But don't think that such a t won't exist. T exists. Just I checked with t as a 2. But if you take t is equal to 2 pi, what happened? Observe what happened. Observe sin of 2 pi plus x equal to sin x only. No? Sin of 360 plus theta sin x only. Means what happened? This sin function is satisfying this definition only. No? For the values of t, 2 pi. T is taken as 2 pi. Sin function is satisfying this condition. Sin of t plus x equals sin x for every x belongs to domain. For every x it happens. No? So for every x, domain all real numbers, no? Domain of the sin function. So sin of 2 plus x equals sin x for every x belongs to R only. What is the meaning of that? Sin function is periodic function. Such t is existing. No? Somebody will ask, somebody will say, sir, instead of 2 pi I will write 4 pi. What happened? Observe here. Sin of, instead of t, that boy want to write 4 pi. 4 pi plus x equal to again sin x only. For every x belongs to R. Sin of 4 plus x or sin x only. So another t existing here. One t is 2 pi. Another t is 4 pi. Existing, no t. That's why sin function is periodic function. Someone saying that, sir, I will write 6 pi plus x. Sin 6 pi plus x equals sin x only. So that by saying that t is 6 pi, sir, okay. T is taken as 2 pi satisfying. T is taken as 4 pi satisfying. T is equal to 6 pi or 8 pi or 10 pi, whatever it may be. Your t's are taken as 2 pi comma 4 pi comma 6 pi comma and 8 pi. All are these positive numbers only, no? You take any t, so again sin function is satisfying this definition. That's why sin function is said to be periodic function. What is first thing? And what is the period of the function? This periodic and next period to find period. So we are getting some t's, no? Among all these t's, smallest one is called its fundamental period. Smallest one. So 2 pi satisfying, 4 pi satisfying, 6 pi satisfying, 8 pi, so on. But among all, 2 pi is smallest one. 2 pi is smallest one. That's why 2 pi is called period of sin function. 2 pi is called period of fundamental period of sin function. Understood? So students, very very important. Periodic function means a function f is said to be periodic function if there exist a positive real number t, so that f of x plus t equal to f of x for every x belongs to domain. Any function satisfies this condition. For any function such t exists, then you can say that is a periodic function. So several t's exist for such function. Among all t's, smallest one is called its period or fundamental period of the function. Now I can say that fundamental period of sin function is 2 pi. Just previous I explained the concept of periodic functions by using graph. There also sin function x values are taken from 0 to 2 pi. 0 to 2 pi. Whatever getting y values are from 2 pi to 4 pi also getting same y values. That's why this length 0 to pi length is the length is said to be the period of sin function. So just now explain the concept of periodic function algebraically. Algebraical definition is very important. Okay. Finally what happened? Sin function is a periodic function. Sin x is a periodic function, or sin function is a periodic function with fundamental period 2 pi. I will write. Yeah, sin function is periodic function with the fundamental period what is 2 pi. Okay. So several t's exist. Among all t's, least one is called its fundamental period. This is the definition. Important. Definition is important. By using definition only, we can find the period of any function. This is one thing. Now we want check the periodicity of cos function. For example, cos x is given. F of x equal cos x is given. We want check the function is periodic or not. If it is periodic, what is its period? Period means fundamental period. Just use the definition. What the definition? F of t plus x should be equal to f of x for every x belongs to domain. Okay. So cos of t plus x equal to cos x1 for every x belongs domain of the cos function is all real numbers. Check t exists or not. Instead of t, you write 2 pi. For example, somebody is saying that I want to write instead of t pi, write pi. What happened? Observe. Cos pi plus x. Cos pi plus x means minus cos x only. No? Pi plus x in third quadrant cos negative. Cos pi plus minus cos x. We are not getting cos x. We are getting minus cos x. That's why t is not taken as a pi here. Understood? So instead of t, you write 2 pi nana. Cos 2 pi plus x equal cos x only. Cos 4 pi plus x. Cos x only. Cos 6 pi plus x. Cos x only. What happened? T may be 2 pi, t may be 4 pi, t may be 6 pi, and so on. Among all these, smaller one is 2 pi. So cos function also periodic function with fundamental period what? 2 pi. So I want to write nana. Okay, algebraic definition is important, students. Algebraic definition is important. Again, I want to write the definition. Okay, periodic function definition. A function f is said to periodic if there exists, the symbol is there exist a positive real say t or sometimes p, or you can say whatever it may be. Period is p. Some books they will give p instead of t. That is not big problem. There is a positive number t such that. So definition important. F of t plus x should be equal to f of x for every x belongs to its domain of that function. Okay, what I observe I want to write. Okay, again I want to write one more thing here. So and least such t is called fundamental period. This definition important. Just now I explain cos function is periodic function with period 2 pi. I will write sin function comma cos function are periodic functions with the fundamental period. Fundamental periods 2 pi. Okay, one example problem. Find period of, somebody asks sin 3x period, we want to find sin 3x. Just to use definition, just to use definition, we will get the answer. Just to definition. What the definition I will write? Yeah, observe that. Yeah, what instead of x, what should write? Instead of x, we need to write t plus x. That's all. So that's why sin of 3 into t plus x should equal to sine 3x. If such a t exists, then you can say that it is periodic function, and among the smallest t is called its period. So I will write in next page that one. So sine of 3t plus 3x equal to sine 3x for every x belongs to R. Everyone knows sine of 2 pi plus theta equal to sine theta. Everyone knows this. Cos of 2 pi plus theta cos theta. Everyone knows this. Okay. So that what is the meaning of that? Again I want sine 3x I want. Sine 3x only I want. So instead of 3 pi, what should write? We need to write 2 pi, 4 pi. So instead of 3 pi, what you can write? 2 pi you can write. Observe here. 2 pi you can write. Sine 2 pi plus 3x, sine 3x only. Or 4 pi also can write. Nothing happens. No? Sine of 4 pi plus 3x, sine 3x only. 6 pi you can write. So on. Instead of 3t. This one 3t. Instead of 3t, you can write 2 pi or 4 pi or 6 pi and so on. But you want t, no? So among this, what is smallest one? 2 pi smallest one. That means 3t should be equal to 2 pi. T should be equal to 2 pi by 3. T should be equal to 2 pi by 3. Now I can say that 2 pi by 3 is the period of the sine 3x function. Simple. Simple. Sine 3x function is given. You want to find its period, just you can say that 2 pi by 3. No need to add any formula, just use definition. By using definition, you can find its period. Somebody will ask another example. Sir, find the period of sine x by 2 plus 7, sir. Okay, you can find what is the problem. Use definition first of all. I don't want to use any formula for this. Yes, use definition first. What the definition? F of x plus t should be equal to f of x. F of t plus x or f of whatever it may be. So instead of x, you want to write t plus x in this function, right? See, sine instead of x, what should write? T plus x by 3 as it is. Okay. By 2, no? Okay, by 2 as it is. Okay, equal to plus 7 also there, no problem. Equal to sine of x by 2 plus 7. More generally, we can write this one as sine t by 2 plus x by 2 plus 7 equal to sine x by 2 plus 7. So clearly. So this value should be equal to 2 pi or 4 pi or 6 pi or 8 pi. No, should among all 2 pi smaller one. So t by 2 should be equal to 2 pi. So what is the value of t? 4 pi. So now simply I can say that 4 pi is the period of this function. 4 pi is the period of this function. By using definition, directly you can find the periods of sine function and cos function. One thing. Next, I want to find period of tan function, cot function, sec and cosec. Okay, students. Yeah. Period of tan function, tan comma cot functions. How to find their periods? Okay, observe. Same definition. First of all, we know that. I will write. We know that tan of pi plus theta equal to tan theta. Sin of pi plus theta not sin theta. Cos of pi plus theta not cos theta. But tan of pi plus theta tan theta only. Tan of 2 pi plus theta also tan theta only. Tan of 3 pi plus theta equal to tan theta only. So on. What happened? Instead of t, we are getting here t may be pi, 2 pi, 3 pi. That's why among these smallest one is pi. That's why pi is the period of tan function. 2 pi is the period of sine and cos function. That is one thing. Pi is the least one. No? 2 pi also satisfying. Pi only smaller than 2 pi. No? So pi is satisfying the condition. Tan of t plus theta equal to tan theta. That means t is equal to pi here. Pi is taken as period of tan function. I will write tan of t plus theta equal to tan theta for every theta belongs to domain. Domain means r minus the angles which are not in the form of n by pi by 2, n belongs to z. Okay. For I will write for t equal to what? Pi, 2 pi, 3 pi, 4 pi. All are positives only. Among all, smallest one is pi only. No? Smallest one is pi. Therefore, pi is the fundamental period of tan function. Important nana. Fundamental period of tan function is pi. Similarly, cot also. Cot pi plus theta, cot theta, cot of 2 pi plus cot theta. That's why similarly pi is the fundamental period of cot function. Period of cot function. Okay, important conclusions nana, these all are. Okay, next period of secant function, cosecant function. Sec comma cosec, same. Okay, secant pi plus theta what nana? Minus secant theta only. That's why pi will not become the period of secant function. Okay, so what is the period of secant and cosecant? Same as sin and cos. I will write it. Secant of 2 pi plus theta equal to secant theta. For its domain, no need to mention. For every theta belong domain I will write. Actually you need to write domain. Secant of 4 pi plus theta also secant theta only. So on. Cosec of 2 pi plus theta equal to cosec theta. Cosec of pi plus theta not cosec theta, minus cosec theta. Observe that one. So cosec of 4 pi plus theta equal to cosec theta. So on. So therefore 2 pi is the fundamental period of sec function comma cosec function. Important. So I am concluding 2 pi is a fundamental period for sin function, cos function, sec function, cosec function. Pi is a fundamental period of tan function and cot function. Okay. Yes, students, very important. What I explained in previously, sin 3x is given. Find its period. One problem. Sin x by 2 plus 7 given. Finding period is second problem. So how I got? By using definition I got. I want to explain once again. Sin instead of x, take care then, instead of x you write t plus x. This should be equal to sin 3x. Such a t should find. First of all, this can be written as 3t plus 3x equal to sin 3x. So instead of this 2t, we can write 2 pi, 4 pi. Given function is 4 pi. So in this way you can find periods by using just definitions. So third example also important. Observe from these three third example I will conclude something. Okay, for example 3 cos x is given. Nana. Actually only cos x given, you can say that 2 pi is a period. But what is given here? 3 cos x is given. Observe what happened. 3 cos x or something, some constant into cos x is given. Okay, so plus 7 also given, no problem. First write definition. 3 cos of, instead of t x you need to write t plus x plus 7 should be equal to 3 cos of x plus 7. So this can be written as 3 cos, observe here, no need to write anything directly. Observe students here, instead of this t we want to write 2 pi or 4 pi or 6 pi. Observe cos of 2 pi plus x, cos x only. 3 cos x plus 7 only will get. Means what happened? Period is what? 2 pi. Period is 2 pi. Important. What is the period of just cos function? 2 pi. Period of cos function is 2 pi. Period of this function also 2 pi. What is important thing is the period is only depend upon x. It is not depend upon coefficient of sin cos function or sin function and constant. Understood? That means the period is not affected with this, and not affected with the constants, means f of x is a function is given, for example its period is t, so a into f of x plus some k given, so still this period also t only, that is my conclusion. F of x is a fundamental period t, the fundamental period of f of x is t, then what is the period of this function, means a into f of x plus k, just no change in function is no change, f of x as it is, its coefficient is different and something k is added, no problem, just we want to say that its period also t only, that is important thing. Students, now I want to conclude. Note, if period of f of x is t, then period of a into f of x plus or minus some b by something some c is also t only. Important. Okay. So another one is if f of 2x is given, different. F of x period is t, no. F of 2x period is different. Just here f of x, no. For example, a problem is going to a into f of 2x plus b by c. We can't say that period of this function is t. We can find period. That is not a big problem. Okay. So, yeah, another note, important note. If period of f of x is t, then the period of something a into f of some bx plus c plus some k is given is fundamental period is t by x coefficient, mod of x coefficient, that is b. Should remember now. Without using this definition also you can solve the problem, that is not a big problem. Just using definition you can find its period, that is not a big problem. Okay, but you should remember. So a into f of bx plus c plus k something is given, we want to find its period. Just what is the fundamental period of sine f of x t by x coefficient with mod. Why mod? Actually the period should be positive, no. Sometimes for example sine minus 3x is given, so what is the fundamental period of sine function? 2 pi by x coefficient is minus 3, you write x 2 pi minus 3 becomes wrong, 2 pi by mod of minus is correct. So what happened? Its period is 2 pi by 3. Period of sine minus 3x function is, actual sine function fundamental period is 2 pi divided by x coefficient minus 3, mod of minus 3 should write, not minus 3. If you write minus 3, the period becomes negative. Period is never negative. There, by definition, the period should be positive. That's why you need to write mod here. Mod of minus, that is 2 pi by 3. Understood? Students, important, Nana. So by using this formula, I can say that period of sine minus 3x is 2 pi by 3. But you don't know formula, just using definition also, you get same conclusion. That is not big problem. Observe here. Sine of minus 3x is given. We want to find its period. First of all, try to simplify this. Minus sine 3x you can write. After that, minus sine of 3 into t plus x should be equal to sine minus sine 3x. Such t should find, or minus sine 3t plus 3x equal to minus sine 3x. Observe here, instead of tt you need to write 2 pi, then only it satisfies. 3t equal to 2 pi. What is t? 2 pi by 3. So by using definition also you got 2 pi by 3 only. So by using formula also you are getting 2 pi by 3. That's the important thing is, we want to find period of this function. If f of x fundamental period is t, we want to find period of this function, just write fundamental period of that divided by what the x coefficient b, no, just you write mod b. Sometimes b may be negative, mod b. This is the fundamental, this is the period of the fundamental period of the given function a into f of bx plus c plus k. Example, find the period of a into or something, wait, 3 into sine of 4x minus 7 plus 9. Directly you can write answer, directly. But sine involved, no? What is the fundamental period of sine function? 2 pi. 2 pi by x coefficient 4, that is equal pi by 2. Pi by 2 is the period of given function. Substitute, you will get the same answer. One thing. Next, if P1 comma P2 comma P3 so on are the fundamental periods of f1x comma f2x comma f3x, sorry, f3x. Okay, up to no so on are there. Just P1, P2, P3 are the fundamental periods of f1x, f2x, f3x. Then important, then the period of a new function k of function is given, like k of x function is given, that a into f of x plus or minus b into f2 of x by some c into f3 of x is given. So P1, P2, P3 are the fundamental periods of this function and this function and this function, but you want to find the period of this total function. That is nothing but the period of k of x is LCM of okay, P1 comma P2 and P3. Through one example I will explain this. Okay students, now I will explain through one example. Observe here. For example, find the period of the function f of x equal to 3 sin 2x plus cos x by tan x by 7. For example, this is the problem. How to find period of this function? So interesting example, na? Just to find period of this, find period of this, find period of this, find their LCM, that gives the period of the fundamental period of the f of x. But before that, one important note I will write here. Here I will write with red color. LCM of fractions. How to find LCM of a by b, comma c by d, comma e by f. We have already formula. LCM of a by b, c by d, e by f equal to LCM of numerators a, c, e divided by GCD of denominators. So this is the formula to find the LCM of fractions. By using this, you can solve problems here. So this should be remembered. Okay. Okay. Now I want to find period of f of x. Just I want to find period of each function. I will write a period of sin 2x is equal to 2 pi fundamental period by x coefficient 2, that is pi. Period of cos x 2 pi only. Period of tan x by 7, 1 by 7, coefficient of x is 1 by 7, fundamental period is pi by 1 by 7, that is 7 pi. Now I want to find LCM of pi comma 2 pi comma 7 pi. Pi LCM pi only. So you want to find LCM of 1, 2, 7, 1, 2, 7, 14 only LCM. So finally I can say that 14 pi is the period of the given function f of x. Okay, this is one example. Another example. Yeah, example 2 I can say f of x equal to 3 sin 4x plus 2 plus sin x by 2 by tan 3x is given, for example. So same, you need to find period of this function separately, period of this separately. The LCM gives the period of the total function. One by one I will write. Period of sine of 4x plus 2 is directly fundamental period is 2 pi x coefficient 4, that is equal to pi by 2. Period of sine x by 2 is fundamentally 2 pi by x coefficient 1 by 2, that is equal to 4 pi. Period of tan 3x function, tan 3x is fundamental period of tan function is pi, not 2 pi, pi by 3. Now I want to find LCM of pi by 2 comma 4 pi by 1 comma pi by 3 is directly. Now just now explain, no, we need to find LCM of numerator, pi only, 1 4 only, GCD of 213, GCD of 213 1 only. So final period is 4 pi, therefore final period by period of f of x I can write. Period of f of x is 4 pi. In this way we can find. Okay, Nana? Important. First one, period of sine square x. How to find period of sine square x? Squares are given. In previous example, all are linear. Sine 2x, sine 3x, sine 4x only. Here sine square x is given. How to find? Just use definition. Don't think that 2 pi is a period squared, that is 4 pi square is the period of this function. Is not correct, Nana. Just use definition, then you can find its period. So I will definition, I will find. Two ways you can find. Observe. The f of x is given as, okay, Nana, sine square x. Use definition first of all. What is that? Sine square, instead of x, what should I write, Nana? T plus x. T plus x should be equal to sine square x. Or another words I can say that sine of t plus x whole square should be equal to sin x whole square. Don't confuse, students, don't confuse. Students, important, Nana. Square is given, important, not cube square. So what happened, Nana? So instead of, actually, what do people can think? Sin t plus x should be equal to sin x, no? So instead of t, I can write 2 pi, 4 pi, 6 pi. Then everyone can say that 2 pi is the period of this function. That is not correct. 2 pi is not period of that function. Okay. So 2 pi is period only, but that is not fundamental period. That is not smallest one. Observe here. Instead of t, you write pi. What happened? Observe pi. You write pi. Write and observe. Pi plus x, Nana, whole square equal to sin x whole square. Sin of 180 plus theta minus sin theta minus sin x whole square equal to sin x whole square. So square is there, no? What is the problem? Minus sin x whole square or sin square x, both are same. So these two are equal. Means what happened? Instead of t, if you write pi, then also satisfying this condition. That's why you can see that among 2 pi and pi, so pi is smaller than 2 pi. No, that's why you can say that pi is the period of this function. Pi is the period of sin square x function. Don't confuse, Nana. By using definitions, you can complete. Okay. So final conclusion. Put t equal to pi. Check. You need to check. Actually, 2 pi will satisfy. 4 pi will satisfy. We need to check pi will satisfy or not. Square is there, no? Will pi also satisfy? Sin of pi plus x whole square equal to sin square x, or minus sin x whole square equal to sin square x, or sin square x equal to sin square x. Therefore, period of sin square x is pi. Don't confuse pi. By using definitions, you can find. This is one of the way to find the period of sine function. So another way is also that I want to explain that also. Okay. So important note, while finding period of any trigonometrical functions, okay, you don't want squares, cubes and 4 powers. We want linear, sin 2x, sin 3x, sin 4x. Easily you can find its periods. That's why I don't want this square. So that's why I want to use cos 2x formula. what is the cos 2x formula? So 1 minus 2 sin square x. Okay, sin square x is made a subject. What happened? 1 minus cos 2x by 2. We want find period of this function. It is better to find period of this function because they are same. How to find period of this function? I clearly explained. No? Don't bother about this one. Don't bother about this 2. So what is the fundamental period of cos function? Fundamental of cos function is 2 pi only. So what is the x coefficient here? 2 only by 2. 2 pi by 2 what? No, pi. Pi is the period of 1 minus cos 2x by 2. That is the period of sin square x. Therefore sin square x period is nothing but pi. By using in this way or by using definition, we get the period of the sin square function is pi. Okay. So important note, students, for any problem is involving squares, cubes, 4 powers. Okay, try to write them as linears, means sin 2x, sin 3x, sin 4x, cos 2x, cos 3x, cos over 4x. Then easily you can find its periods like this. Sin square x is given. I don't like square, no. That's why sin square x is nothing but 1 minus cos 2x by 2. Just finding to find the period of sin square x, that is same as the finding period of 1 minus cos 2x by 2. Just to consider fundamental period of cos 2x is 2 pi. Don't bother with the minus also, that is not a big problem. 2 pi by 2, that is pi. Pi is the period of this function. Okay. Yeah, what is my note? Means sin square x, cos square x, sin power 4x, cos power 4x, even powers, so on, are having periods pi only. Okay, another important note. Okay, sin square x given, mod sin x given, we want to find its period, mod sin x. Mod sin x is given. I can say period of mod sin x also pi only. Don't think that 2 pi, pi only. I will show you. Sin of t plus x equal to mod of sin x. Put to t equal to pi instead of 2 pi. 2 pi will satisfy obviously. Need to check for pi. So mod of sin of pi plus x equal to mod sin x. So sin of pi plus minus sin x, mod of minus sin x equal to mod sin x. Mod of minus mod sin x, that is not a big problem. Mod sin x को mod sin satisfying, no? What is the meaning of that? Pi is its period. That's why comma mod cos x, comma mod tan x. Actual tan x period also pi only, no problem. Mod tan x, mod cot x, mod secant x, mod cosecant x. These all are having periods pi only. Are having periods pi. So next note, Nana. Just this is not useful only. Sin nx, comma cosec nx. Okay, and cos nx, comma secant nx. So the periods are pi if n is even. Or 2 pi if n is odd. Students, my sincere advice, if you don't know any formula, just using definition you can find its period. That is not big problem. Okay. Yeah, next important, this is also another important result. Prove that sin x square is not periodic function. Sorry. So the student, very important, this one, very important. Sin square x differ from sin x square. These two are different. Observe, Nana. Angle is squared here. Angle is squared. Your total function is squared. Observe here. This is nothing but sin x whole square. This is only sin x square, angle only squared. The total function is squared. So these two are not same. So what is the period of these functions? You can say simply pi. Pi is the period of sin square x. No? Sin x square actually is not periodic function. I will prove. Actually, you want to prove that sin x square is not periodic function. So I want to prove indirect method of proof. Let us assume that is a periodic function. Okay. Let us assume t is the period of sin x square. Okay, if it is a period, what happened? Sin of x means t plus x whole square should be equal to sin x square. What values of t this happen? Observe all of you. What t it's happen? Very, very important. What t this becomes equality. Only one t, that is 0. If t equal to 0, only this. If t equal to 0, then only this statement is true. Then only this statement is true. But t, what is our definition of period and not? Period should be positive. 0 is not positive number. T is satisfying here. T is satisfying. But what t? 0. Only for 0 it is satisfying. But 0 is not a positive real number. If we want to define a period, that should be positive. That's why this is not a periodic function. Means that is there is no such t exist. But 0 is not positive real number. So sin x square is not periodic function. Students, important, hai na? Spelling wrong. Okay. Function important. So finally, what is my conclusion? Yeah, note sin x square, cos x square, tan x square, like that, root x. Okay, just x square, just x cube, these all are not periodic functions, are not periodic functions. So one will ask, sir, how can you say this is not periodic? I will show what is the problem. So instead of t, what should I write? Instead of x, t plus x should write equal to root x. When this happens, only one value of t, that is equal to 0. 0 is not a positive real number. That's why it is not a periodic function. Somebody will ask, how sir? Just to write definition, t plus x whole square should be equal to x square. What happened to t? T only 0. That's why this is not a periodic function. So somebody will ask, how sir? So t plus x whole cube equal to x cube. When this happens, only t equal to 0, then it is true. So t is 0 is not a positive real number. That's why these all are not periodic functions. Another example, important, concept only important actually. Yeah, important. Find the period of mod sin x. Oh, what is the problem? Mod sin x, pi only, no? Mod cos x. Oh, what is the problem? Pi only, no? Between them plus is given. Interesting. Most of the students will make a mistake here. How means mod sin x period is pi, mod minus cos x also period is pi, LCM of pi and pi is pi only. They will write pi is the period of this function. But pi is period only, but not fundamental period. They will ask always period means fundamental period should find. So pi is period only, but pi is not fundamental period. Pi by 2 is fundamental period. I will show you. Observe here. Mod sin x plus mod cos x is given. Use definition, mod of sin of t plus x plus mod of cos of same t. Here t means that t should be right here, t plus x. should be equal to mod sin x plus mod cos x. Okay, students, put here x is equal to pi. Then what happened? Sin of pi plus x minus sin x, mod of minus sin x plus mod of cos x equal to mod sin x plus mod cos x. What is the meaning of this? This is sin x, mod sin x plus mod cos x equal to mod sin x plus mod cos x. What is the meaning of that? X equal to pi satisfying. X is equal to pi satisfying. But what is important thing? That is not the least positive. It may be x another least positive. I will show you pi satisfying. Than that, I will show you there exists another positive number which is lesser than that. Put pi by 2. Put pi by 2. So this is interesting problem, Nana. This is interesting problem. Okay, put pi by 2. What happened? Observe, Nana. Modulus of sin of pi by 2 plus x plus modulus of cos of pi by 2 plus x equal to sin mod x plus mod cos x should be equal. See here, sin 180 sin 90 plus theta cos theta cos x mod cos x plus mod of cos of 90 plus theta minus sin x, actually mod minus sin x equal to mod sin x plus mod cos x only. Observation, mod of cos x as it is, mod of cos x only. What happened? This is mod of sin x equal to what we got? Mod of sin x plus mod of cos x. Means what happened? LHS equal to RHS. What happened if x is equal to pi by 2 satisfying? No? So the pi by 2 is smaller than pi only. So pi is satisfying, pi by 2 also satisfying. So this is smaller than pi. That's why pi by 2 is taken as the period of the given function. Therefore, period of given function is pi by 2. Should take care, and I will find a period for modulus functions. Yeah. Note one by one. All trigonometrical functions are periodic functions. Sorry. Okay. Second one, algebraic functions are not periodic functions. So this is important, Nana. All trigonometrical functions are periodic functions. Algebraic functions are not periodic function, except one, that is called constant function. In next part I will explain about that. Except that constant function. Constant function is also algebraic function only. So that is periodic function. I will explain about a constant function and the remaining functions. This is the part 1, Anna. So part 1 is important. In part 2 I will complete the concept of periodic functions. Okay.